It's called NAS, but it doesn't have to be nasty.
There are different types of this nucleophilic acyl substitution. The first one, where it's neutral, so we're using water, there's no catalyst needed. We'll see this when we're converting an acid chloride or anhydride to carboxylic acid. The reason why we don't need a catalyst is because these are already really reactive. Remember, these are at the top of our list of reactivity, being the most reactive. That's why we do not need a catalyst to convert this into a carboxylic acid. However, when we go down the list of reactivity and these are no longer as reactive, like an ester, we do need a catalyst. In this case, we're going to use acid. This allows us to go from an ester to a carboxylic acid, and our byproduct would be an alcohol. This is a reversible reaction where we can go back from a carboxylic acid to an ester, but we'll get to that later on. Another type is base catalyzed, where we're going to see a strong base, and we will need to use acid to then protonate that carboxylate and get to a carboxylic acid. So notice for all of these, acid chloride, anhydride, ester, amide, we'll use a strong base. All of these give us a carboxylate. From there, we protonate using acid, and this gives us our carboxylic acid, and our byproduct would be different for each one. For an acid chloride, we just get HCl. For an anhydride, we do get multiple carboxylic acids. For an ester, we get both a carboxylic acid and an alcohol, while an amide is going to still give us a carboxylic acid, but it's going to give us an amine as a byproduct.
For step-by-step explanations and practice problems, watch this full video on Community.